Right, folks, this video is to supplement what Mr. Andrew Sargent has done, his 3 videos here. I'm squeezing it in between the bottom one here, which is where he talks about his discussion. By the way, this is his time to drain, and if you click on this one here, that'll take you to very old-fashioned by hand. My goodness, doing this by hand is fiddly work. His calculations here, and this is his discussion, and where he talks about his what his findings are. So that is so I'm going to basically modernize it. That's the word I'm going to use, but put it onto a spreadsheet and use the tools like NZGrapher to get me the line of best fit data, line of worst fit data, and with that data do the analysis and just see how good the relationship is. Now, what is the relationship? It's reasonably intense. It's this thing here. So the first thing I want to do is we're going to copy this relationship on a piece of paper, and we're going to dramatically simplify it. And why do this? Let's just do this very quickly. Okay, so that is okay. To be honest, that is yuck. Yuck. Let's replace that with k. So we're going to say t equals k square root hi minus square root hf. And if we were to expand this out, you could say t equals k square root hi minus k square root hf. Don't forget this k being this horrendous stuff here. Okay. In fact, just before we proceed, let's just do some substitution here. What is the k value? So if we look carefully at this document here, scroll right to the top, I notice there's some, I'm just going to write here, big D is 0.09, little d is 0.005, and C is 0.61. Okay, so if we put those numbers into this thing here, so for example, 0.09 squared over 0.005 squared times 0.61, 2 over 9.8. And if you put on your calculator, you have to trust me here, but out pops this answer here, 2, 3, in fact, I'm going to call that 240. Out pops 240. Okay, so we're going to come back to this. So the theoretical k value, or in this case, if we look at this here, if we were to graph this, if we put underneath here y equals mx plus c. Now, very quickly, I hope you realize that the hi is your independent variable, okay, and the dependent variable is time, and hf is another constant. So we've got this k constant, which has all these other constants up here. So what you've got here is basically a graph like this. So maybe here's the data points here. If we put y-axis is time in seconds, and the x-axis here is the square root of hi, and that unit is the square root of m, we would get this relationship here. So what it basically says is there's going to be a y-intercept, and that y-intercept is negative, 240 square root hf. And the gradient here should be what? 240. So there is your challenge. Can we take the data? Can you collect your own data? Or okay, can you? In fact, we're going to cheat here slightly. We're going to take his data here, and I'm going to put it into a spreadsheet here. Hang on, let's just delete that. Okay, so that just excuse me, just want to correct this. Hang on, take that. Okay, the 9 there. So that's the relationship we're trying to investigate here. So there is the stolen, copied results. I haven't done the experiment. I'm just going to use his data, which is a shame because if I'd done his experiment, I would have come across issues that can only be discovered by doing the actual experiment, by actually collecting the data. What are the limitations? What were the errors potentially? What was difficult about getting the data? So you only get that knowledge by actually hands-on collecting the stuff. So let's just assume this is all the good legit. And basically, there's his height, HI value. This is HI. Here's his average time. And here's his uncertainties, which he's determined from the half range rule here. Okay. And basically, that's his calculations there. So if we take that into the thing here, I've assumed that we've got an error, let's say 5 millimeters, plus or minus 5 millimeters to every distance here. So that does, the percentage error does mean it's a 25% error here. I've square rooted. Why? Because the relationship says if you square root it, we'll get a possible linear relationship. Okay. So there's the relationship there. If we did put the square root, we would get this linear line, and we'd get this following this, y equals mx plus c perspective here. Okay, this is fiddly. What is the uncertainty attached with the square root value? Well, because we're square rooting the HI, we basically halve the percentage error. So that's why 4.2 has come 2.1. That's why 25 has dropped down to 12.5. And what is 12.5% of these values, or 6.3% of that? That is this value here, and that's been rounded to one significant figure. So there is your data. Now, just as it happens, I've already got this pre-programmed. So basically what I've done here is I've put the horizontal axis is the square root of HI, and the vertical axis, your dependent variable, is the TF. And I've basically gone down here and included the error bars. Okay, where are those error bars from? There's the half range rule. So for example, 0.6 uncertainty. This one here, 0.66 would be 0.7. This one here, 0.37 would be 0.4 uncertainty. So those values, there's the uncertainty for the time data. And if we look at the actual graph, here's the graph here. Now, who spotted a mistake on here? Okay, I've had to go and I've put here on the options -30 for the Y, but it hasn't adjusted the x-axis or the horizontal axis to go through here. So that is a mistake. That is a technical issue which I need to get some help on, but that is a limitation to do with NZGrapher here. But guys, you're not going to get it this hard in the actual assessment. So here's a challenge. Let's just tweak this slightly. Let's go drawing. And let's just insert an imaginary horizontal axis that goes to 0 here. And so basically, this bit here should be along this line here. So that is our relationship. Let's just put this back in here. Okay, it's not wanting to move. Right, and so as we can sort of see, there is a negative intercept, as you can expect down there. So the challenge now is, can we take this data here and can we work out a line? Can we get uncertainties attached to this gradient? Can we get a value and see if it compares to this 240? Let's do it. So scrap piece of paper. Righty, so let's go to here and let's just zoom in to this bit here. So we're going to say line of best fit, t equals 245 square root hi minus 25. Line of worst fit, t equals 216 square root hi minus 18. So if we then simplify this, the difference between these two is what, 29? So we're going to say t equals 245 plus or minus 29 square root hi minus 25. What's the difference between these two? 7, so plus or minus 7. And to get the final result here, your conclusion statement, make that 30, so plus or minus 30. That's the 10th column, so it's going to be 250 plus or minus 30 square root hi minus 25 plus or minus 7. Okay, so there's definitely going to be a y-intercept, a negative y-intercept. Even with the uncertainty of 7, it will not take it to 0. So there's definitely is a y-intercept there. Hey, 2200. My apologies. I've just been talking the screen there. Sorry. Oh dear. Okay, it's time to go home. But hey, look, what I've just been talking about is there's line of best fit, there's line of worst fit. That minus that gives you 29, which simplifies down to 30. And I've made 245, 250. So that's the 10th column. That's the 10th column here. Difference between these two is plus or minus 7. So 25 plus or minus 7. There is your relationship. How does that compare? It compares very well with the theoretical value of 240. That's exceptional. Look at that. 250 plus or minus 30. If you take it down, you will definitely get overlap. So what that means is, because theoretical gradient compares to the experimental gradient, you can say what? You can say that this relationship is actually feasible. It does work for that small scale, but that's another question. If you upscale it to, in this context, a big reservoir, would that still work? Now that's something you could talk about in a discussion question. But hang on, we just missed out one key feature. Now this time, what about the y-intercept? Let's just do that analysis, and this time I'll record it. In theory, there is a y-intercept here, so let's just do it. So in theory, it should be negative 240 times the square root of HF. Now, what the heck is HF? Don't know. Let's see if there is a value here for HF. There. HF is 0.01. Okay, useful. So we're going to go back to here, and we're going to say 0.01. Let's go to the calculator. Neg 240 times 0.01 to the power of 0.5. It comes to be negative 24. Interesting. Okay, check that out. Look at that. Negative 24, negative 25 plus minus 7. That is a spectacular result. Okay, so you can sort of see the results there do match quite well. Okay, now, who spotted the classic error here? Okay, the classic error is we've done some calculations up here involving values. Each one of these values technically should have an uncertainty. I'm just going to make up some uncertainties here. In fact, this one here, I would say is you can argue it's a 10% uncertainty. Okay, let's just say 1. So all these guys here, without us, each one of these in theory has an uncertainty which you do need to factor in. So what it basically says is you might actually get a value here of 240 plus or minus, I don't know, I've just made that up. Let's say, if you factor in these uncertainties in this theoretical calculation, you actually get an uncertainty value. But the key thing here is they definitely overlap. Okay, so they're definitely a legit thing. Okay, that was pretty intense. By the way, if you did scroll down with Mr. Gallagher here, he's a good practitioner here, and you will see that what I've just been doing on the piece of paper here, he's actually done the same thing here. Look, he's worked out his theoretical gradient to 239, 240. We just worked out ours to 24, same as him. Okay, so yeah, and so what I need you to do now is you should basically read through. We'll let him explain his discussion. That's even better than me explaining it. So much better. Okay, team. So that'll appear here. And hey, take heart. It says here, why do you think I've said this is harder? You're not going to get a negative intercept. That's quite complicated. Your NZGrapher is going to do the job for you. You don't have to fiddle with NZGrapher like I was doing here, okay, to get a visually correct graph there. Right. Hope that helps.